Hello all. Now today we're going to troubleshoot this circuit right here and find out what all would make it not work. Now on the input side, now I'm going to reference my meter to ground right here, ground of the power supply. So I'm going to put my black meter lead on ground and I'm going to probe around the circuit. On the input side, if I put my meter right here on pin 1 with this switch open, I will measure VCC. Now I've dropped VCC back to 11 volts in this troubleshooting example. So we have VCC as 11 volts, and I put my red lead here, or I'm sorry, I put my black lead here, and I put my red lead here, and with the switch open, I'll have 11 volts. Now when I close this switch, that connects the cathode of the Opto Coupler's LED, input LED right there, to ground. And now we have current flow through here. So with my meter lead still up here, my black lead down here, my red lead up here, and I close that switch, I'm going to be measuring the voltage drop across the LED inside that Opto Coupler. And it's going to be anywhere from 1.1 volts to 1.2 volts thereabouts for this 4N35. On mine, with VCC set to 11 volts, I've got about 1.175, if I'm recalling correctly, when I close that switch. So I'm looking up here with the red lead, black lead here, close the switch, and I've got about 1.175 from pin 1 to ground. Pin 1 to ground. We're referencing everything to ground. If we don't have that, there's a couple of things that might be going on. This switch might be bad, or I don't have connection to pins 1 and 2 with the rest of the circuit. Or, and I've done this before, breadboarding ICs, putting them on a breadboard and wiring them up. And don't tell nobody, because this is pretty embarrassing, but I have actually put the IC in backwards, so that the output transistor was connected over here to the input side, and the output circuit was connected to the input side. It happens, believe it or not, and I've done it myself. So that might be one thing to check there. On the output side, what you're going to see is, if you go here, ground, these grounds are the same. So put your black lead on ground, power supply ground. If you put your lead right here between the resistor and the anode of that green LED right there, you're going to see VCC of we've got it set to 11 volts on the circuit right there. Now if we go to the collector side to ground, we're going to see roughly 9.8 volts, 9.5 volts. I think mine's 9.5 something. This is with the switch open. That's what we'll see there. And that's on the collector. When we push the switch, what we see is reference to ground. We push the switch. The input LED drives into the base of this Opto Coupler transistor here, and now the collector emitter junction is in real world on my circuit, it's about 0.2 volts, very close to 0 volts. We got a storm coming in. There's some dark clouds looking out the back window. Hope it don't knock the power out. So, if we're looking over here with the switch turned off, reference to ground, we see the source voltage. And when we turn the switch on and connect the cathode of that input LED to ground so that it's turned on, emitting photons into the output transistor of the opto coupler, this voltage right here, reference to ground, drops down to about 2.2 volts right here between the resistor and the anode of that green LED. And then if we're looking at the collector to ground of that optocoupler NPN transistor, we've got about 0.2 volts for my circuit, and that's if everything is working. So let's go look at the real circuit, and we'll look at the voltages in the real world there. Okay, now we're going to take some measurements in the real world. Shoo! You hear that thunder out there? I hope y'all can see this. Well, I tried to get the schematic and the circuit and my meter all in the same camera view. Now over here, I got the black lead of my meter tied to power supply ground right here. Right here's power supply ground. Let me get that over there. And I'm going to reference all our voltages to ground. So we don't have to move that. Once we get that black lead connected to ground, we don't have to move it. We'll just leave it right there with this clip lead. I've got the power supply. Let's see what I've got it set to. Get on there. Okay, let me back that off a little bit. I'll get it right at 11 volts. Alright, that's close enough. That's 11.03 volts we're using for VS right here. Now, when you're troubleshooting this circuit right here with our black lead on ground, we want to go here to pin 1 on the opto coupler. So that's this pin right here. Now let's see what we got. Okay, we've got 11.03 volts. That's because this switch is opened. We haven't closed that switch yet, so we're measuring from here to ground. We've got 11.03 volts. Now I'm going to close this switch, and we have on my circuit 1.176, and the output transistor is turned on and allowed current to flow through that LED and turn that LED on. Now this voltage that we're measuring right here, that is the voltage across the input LED of that optocoupler. If you don't see that voltage across the input LED, there's a couple of things might be going on. We might have an opened up resistor here, or no connection between the source voltage, that resistor, and pin 1. Or we might have a bad switch, or no connection here from pin 2 to the switch, or the switch to ground. To test the switch to ground, let's go over here to pin 2. Now we were on pin 1, and we saw the voltage drop across the LED, so we know that switch is good. But let's say that we didn't see that voltage right there. Let's say it didn't switch, it stayed at 11 volts DC. Let's go to pin 2, and we're going to push the switch again. Alright, did you see that? We had 10.25 volts on pin 2, and we closed the switch and it went to 0 volts. Now, if when you close the switch and it did not go to 0 volts, that means that we have bad connection from pin 2 to the switch and from the switch to ground, or we've got a bad switch. And that's if we don't see that 10.26 volts or thereabouts. It's not going to be exactly the same for your circuit, but pretty close from here to ground. If it does not switch to ground, check that switch right there in the connections. Now on the output side, we just took care of the input side, troubleshooting that. On the output side, if you go from between this resistor here and the anode of that LED, we have pretty close to 11 volts. It looks like my power supply dropped a little bit there. Yeah, it did. Let me crank it back up a little bit. Get it back up above 11 volts. Now our source voltage is back up to 11.05. So if we go here between the resistor and the anode of that green LED, we have 11.05 volts. Let's see what happens when we turn this switch on. Alright, we drop down to 2.213 volts between that resistor and the anode of that LED. Now let me go here to the collector of the transistor. We were here with the black lead on ground. Now let's go to pin 5 of that opto coupler. We have 9.52 volts DC right there. Let's see where it goes when we push that switch and we drive that transistor into saturation. Alright, we just dropped to 0.223 volts, 223 millivolts with that switch closed. Alright, now that's how you go around and troubleshoot this circuit, what voltages to look for. If the LED doesn't turn on, we could have a bad optocoupler. We could have a bad LED. We could have an opened up resistor here, or bad connections between this circuit right here. Now what I'm going to do now is I'm going to turn some stuff around. Let's see what happens when we turn some stuff around. That'd be an interesting thing to do. Let me turn my power supply off. First thing I want to do is I want to turn this LED around so the cathode is pointing toward the source voltage through the 1K resistor, and its anode is in the collector of that NPN output transistor inside the optocoupler. We'll see what kind of voltages we get when we turn this around, because as I was saying earlier, I've done that before. It's real easy to do. Let's turn that around. So now the cathode is pointing that way toward the source voltage, and the anode is pointing toward the NPN transistor inside that optocoupler. Let's see what kind of voltages we get now. Alright, there's our source voltage of 11.08 volts. On the cathode now, I put it in backwards of that green LED. Let's see what's on the anode there on the collector here. Huh, that's interesting. It's only 700 millivolts. It's not 9 point something anymore. It's only 700 millivolts. That's very interesting. Okay, will it work if I turn it on? No, it don't work. Okay. Let me turn my power supply off again, and I'll put that green LED back in the correct orientation. That was very interesting. What's happening is, when we have the cathode pointing toward the source and the anode here at the collector, we have a reverse bias diode, so we don't see any voltage down here. That's very interesting. Let me get that turned around in the correct polarity so that the anode is pointing toward the source, the cathode is pointing toward the collector. Turn my power supply on, make sure my circuit's still working. Yep. Okay. The green LED comes on when I push the button. Now, you know what I want to do? I want to turn that opto coupler around. And that would, you know what that would do? That would put the input LED down here so that the cathode points that way and the anode is on ground, which would be another reversed diode, and it would put, let's see if I get it turned around, it would put pin 4, the emitter, up here on the source, and the collector on our switch. Let me get that turned around. We'll see what happens if we do that. The power supply is turned off. Oh, listen. I need a chip puller. Oh, I hope I don't bend those pins. Okay, I got it out. And I'm turning it around. Let me get it put where it's supposed to be. Okay, now our opto coupler is backwards in the circuit. Let's see what happens now. I'm going to turn the power supply on. Let's go to the input side. There's our source voltage, 11.11 volts. My power supply for some reason keeps going up. And there, that would be the collector of the output transistor as it's sitting on the input. Well, what happens if we turn it on? It goes to 0 volts on pin 2, which you would expect, tied directly to ground. And pin 1, that's interesting, pin 1 goes to 9.46 volts DC. That's interesting. Well, let's see what happens on the output side. Okay, I'm going between the resistor and the anode. We have 11.13 volts. Let me push the button. It's kind of crazy. It does switch somewhat, but not like you would expect. It doesn't fully turn on. So when I push the switch, we have 9.79 volts. Now let's go to the cathode of that green LED. It drops from 9.56 to 8.24. And those aren't correct voltages to function. Let's see what's happening. Oh, look at that. That's what's going on. When I push this button, I'm pulling the source voltage down to 9.77 volts. I don't have a very beefy power supply here, so it droops when things ain't right. So let me turn that off, and I'll get that opto coupler put back in. Let's see if I destroyed it. I might have broke it. Let that power supply. Oh, I keep sliding around over here. Let me get this off and turned around the right way. Let's see if putting it in backwards destroys that opto coupler. Okay, there we go. We're back in. The LED is in the correct orientation. The opto coupler is in the correct orientation. Let's turn our power supply on. Ah, I didn't break it. It still works. Okay, alright. And that's how you troubleshoot this circuit right here. What voltages you will see as you turn this circuit on and off. And the things that can go wrong in this circuit. There's a lot in that circuit. It looks like it's a very simple circuit, but there's a lot that could go wrong. Very much that could go wrong. This guy right here could be bad. The switch might be bad. All kinds of things that can go wrong here. Alright, I hope you enjoyed that. That's how you troubleshoot an opto coupler. Hey, wait a minute. Now let's do this. I forgot. Let's do this. Let me get unbuckled from ground. I'm going to turn the power supply off. I'm going to get off of ground here. There's some static tests. We just did a dynamic test on that opto coupler, the LED, the resistor, the switches, and the connections. But there's also some static tests that you can do. I need to undo that power supply so we don't have any residual voltage in the circuit there. I'll undo my 11 volts DC from the circuit. Now, if your meter has a diode test, set your meter to diode, and you want to put your red lead here and your black lead here. That's the red lead on the anode of the input LED inside that opto coupler, and the black lead on the cathode of that opto coupler. On the output side, you have an NPN transistor. Here's the base on pin 6. Here's the collector on pin 5. And here's the emitter on pin 4. So this is an NPN transistor. You take your red lead on pin 6 and your black lead on pin 5, and you should have a diode drop. You put your black lead on pin 4 and you should have a diode drop. Very simple static test to determine whether this is good. So red lead here, black lead here, and you'll have an LED diode drop. LED diode drops are up above 1 volt out of circuit. So we'll see maybe 1.05. Over here we got an NPN transistor, so from base to collector and base to emitter you might see 0.7 volt diode drop. So let me bring the circuit over and we'll do those tests. Okay, so here is the input LED. The anode is on pin 1 and the cathode is on pin 2, and we have a diode drop. That's a good LED diode drop on an opto coupler of 1.059. Now we'll go over to the output side. We put the red lead on pin 6, that's the base, the black lead on the collector, and there we have a diode drop of 0.704. Now we go from base to emitter. We have a diode drop of 0.714. Those are good diode drops right here. Now let's go collector to emitter. Okay, we've got an open circuit, that's good. Now let's reverse the leads. We'll put the black lead on the anode of that input LED, and we'll put the red lead on the cathode. We've just reverse biased that LED, and you can see it's open. That's good. Let's put the black lead on the base. We're reverse biasing that NPN transistor inside the optocoupler. Red lead on the collector, it's open, that's good. And red lead on the emitter. That's good, it's open. Static test of that optocoupler tell us that it's good. Okay, so the last thing we're going to check in that circuit, troubleshooting wise, is we want to know if that green LED is good. Let's say if that green LED wasn't lighting up, and we know it's oriented in there properly, the anode pointed toward the source, and the cathode of that LED connected to the collector of that output opto coupler, NPN transistor that's inside there. So how do we know if that green LED is good? Well, we can check it with our meter. If your meter has a diode function, you select diode. That's the same function that we used to check the opto coupler just a little bit ago. Let me turn on the LCD there so we can see what's going on. You take your red lead of your meter, put it on the anode, and you take the black lead and put it on the cathode. Oh, I slipped off there. And look at that. We have a diode drop of 1.812 volts across that LED, and we turned it on with the meter. Is that fascinating? That is fascinating. Now that's another way to tell who the anode is and who the cathode is. Red lead on the anode, black lead on the cathode, and we light up that LED. Now if I turn it around so that the black lead is on the anode and the red lead's on the cathode, I have an open circuit. It doesn't turn on. So you can determine the correct polarity of that LED right there with your meter. Okay, and there you go. That's how you troubleshoot this circuit right here. Thank you very much for watching, and we'll see you next time.